All right, so here we go. Practice test or review for test 15. The first three are just inverses. They're asking you, okay, where is cosine squared of 3 over 2? Hopefully you know, at the power 6. Where is sine negative squared of 2 over 2? Remember sine, you can use quadrant 1 and quadrant 4. So I'm going to say negative power 4. And then number 3, where is tangent squared of 3 over 3? At power 6, because there's two 3's. Remember, 2 3's means power 6. Number 4, if I use the calculator. First of all, make sure your calculator's in radians. We're going to hit inverse cosine of 4 ninths. Hit enter right there. Let's go 4 decimal places. I'm looking at 1.1102. That's all you got to do in that one. 5's a little tricky. Not really, but this is saying what is cosine of negative power 6? Cosine of, always work inside out. Cosine of negative power 6 is square root of 3 over 2. Now it's asking you, where is cosine square root of 3 over 2? Well, power 6, and that's your answer. Now, remember this, whenever you need an inverse cosine answer, it's going to be in quadrant 1 or quadrant 2. If it's inverse sine or inverse tangent, you're looking at quadrant 1 or quadrant 4. Number 6, simplify this thing. A lot of ways you could go here. I think the day we did this, we pretty much changed everything to sines and cosines and just did the math. So I'm going to change the secant to 1 over cosine. Now all I see here, I can't really add the top. I'm kind of stuck with this on my numerator. My denominator though, I can do some addition. So I'm going to add these. My denominator is cosine, cross multiply, get cosine x plus 1. Now that fraction bar right there means divide, which in my mind means keep, change, flip. So I'm going to keep the top, change it to multiplication, flip the bottom, which means I'm putting cosine on top and cosine x plus 1 on the bottom. Hopefully you see this. Those two cancel. I just get cosine. No matter what's on your test tomorrow, it should work out pretty neat like that. So just simplify as far as you can go. Okay, number 7, 8, 9. Verify these identities. You know the answer before you start. I got to take that left-hand side of number 7 and make it be cosecant. So don't just sit and stare. Remember, try something. If you don't know what else to try, change everything to cosines and sines like I'm doing here. So cotangent is cosine over sine. And then do as much math as you can. Eventually stuff's going to work out. So if I multiply those two, I get cosine squared over sine. And now I'm just going to add those fractions together. So if I multiply the denominators, I get sine x. If I cross multiply, I can see what's going to happen already. I see it taking shape. So sine squared plus cosine squared on the numerator. Remember, that's always 1. So get 1 over sine x. Remember, 1 over anything means reciprocal of that. What's reciprocal of sine? Cosecant. And there's 7. Number 8. Again, do the math here however you want to go. I'm noticing something though. If I see 1 minus cosine squared, I'm thinking, man, that looks awfully familiar. Like sine squared plus cosine squared is 1, which means 1 minus cosine squared, that is sine squared. Love it. The second one, 1 plus cotangent squared, that's on your sheet also. 1 plus cotangent squared is cosecant squared. Now let's change and see if we can simplify. So that's sine squared right there. Cosecant squared is 1 over sine squared. Sine squareds cancel. Look what I got. Are you kidding me? Just 1. That's what I needed. Number 9. This is a good one. Now, if I'm sitting there looking at this, I have a cosine squared over here, but I've got a sine squared over there. So somehow I've got to find a way to change a cosine squared into a sine squared. And here's how you do it. We're going to use this thing right here. We're going to use sine squared plus cosine squared is 1. So think about this. What is cosine squared? Cosine squared, if I move that over, it's 1 minus sine squared. So I'm just going to replace that cosine squared with a 1 minus sine squared. Still got the minus 1 because I'm trying to get this. That's my goal right there. So let's distribute the 2. If I distribute the 2, I get 2 minus 2 sine squared x minus 1. I have a 2 and a minus 1. 2 minus 1 is 1. And it leaves this. Are you kidding me? That's all you got to do. Number 10. Addition and subtraction. Okay, you gotta find ways to write these. So 75 degrees, that one's not too bad. 75 degrees, you can write it sine of 45 plus 30 or 30 plus 45, doesn't really matter which way you go there. So I'm looking at my sheet for like sine of x plus y. Sine of x plus y is sine 45 cosine 30 plus cosine 45 sine 30. Right now, let's fill in the numbers. Sine 45 is square root of 2 over 2. Cosine 30 is square root of 3 over 2. Cosine 45 is square root of 2 over 2. Sine 30 is a half, which gives me, if you look at all those numbers right there, that denominator is 4, that denominator is 4. So I'm going to go, let's make it all 4. These two, if I multiply those, I get square root of 6. These two, if I multiply those, I get square root of 2. There's your final answer for number 10. All right, number 11. Cosine 17 power 2. A little more challenging here because you got to find some way to write 17 power 12 using, your fractions. So one thing I know about 12 on my denominator probably means there's a 4 and a 3 down here. Probably addition, because 17 is such a big number. I'm trying to think in my head, what if I were to put 3 pi here and 2 pi here? And think about cross multiplying right there. If I cross multiply this that way, that's 9. That way, that's 8. 9 plus 8 is 17. I got it. So that's cosine x plus y. It may take you a minute to get that. I did it a little quickly just so I could get the video not to last so long. But it may take you a couple of minutes to get that. Don't afraid if it takes you a minute. Cosine x plus y is cosine cosine minus sine sine. And I'm just following that straight off my identity page. Okay. Cosine of 3 power 4, that's in quadrant 2. This would be negative square root over 2. Cosine 2 power 3, also in quadrant 2. Negative 1/2. Sine 3 power 4 is quadrant 2, but sine's positive in quadrant 2. And that's quadrant 2, but again, sine's positive. So if I multiply these two, first of all, let's do the same thing. The denominator is 4 again, just like the last problem. Negative times negative is a positive, minus square root of 6. There you have it. And then number 12, let me erase this one. Number 12, there we go. Going backwards. This one says cosine cosine minus sine sine. So I'm looking for, on my paper, on my identity page, I'm looking for cosine cosine minus sine sine. And it says cosine x plus y. So that's my x, that's my y. So if I do cosine x plus y, I get cosine 90. Now, if it's one we don't know, you can stop right there. But this one we do know, 90 degrees, cosine 90, that's at the top of the unit circle. And the x-coordinate there is 0. So it's 0. Number 3, prove this, another identity. But this one's not a question of what to do. Like, you don't have to sit and figure this out, because this one is sine with the subtraction. So I'm going to do sine x minus y. So I get sine x cosine power 2 minus cosine x sine power 2. And I got that right off the identity page. Okay. Cosine power 2, 0. Sine power 2, 1. All right. 0 times anything, that's gone. That leaves me negative cosine x, which is exactly what I needed to get. Number 14, almost there. Number 14. Start off, let's move that 1 over. It's been a while since we've done one of these. Let's move that 1 over. Then I'm going to square both sides. If I square that side, I just get 5 minus x. If I square this side, I'm going square, multiply, double, square. And because I have a square, I need to move everything over. I'm moving the x over, it gives me negative 5x. Move that 5 over, gives me a positive 4. Factor that thing, get x minus 4, x minus 1, which gives me these two answers, 4 and 1. Now, don't forget, anytime you do a radical equation, you got to check your answer. So if I plug 1 in, first of all, if I just plug it in over there, I know it's not going to work. 1 minus 2 is a negative 1. You can't have a radical plus 1 and get a negative number. That's out. If I plug in 4, works great. There it is. Now, this is a reminder, one answer, you may get one solution, which is okay. Both solutions may work, and you may get no solution, right? All that's possible. 15, find this inverse. Also been a while since we've done this. So take your x and y and switch them. So get the x over here, the y over here, and then you gotta get the y by itself. So I'm gonna cross multiply. That's really x over 1. So I'm getting x times y minus 2 times x. 1 times that top is y minus 2. You need to get your y's together. So I'm going to switch places with those two, which gives me xy minus y equals 2x minus 2. Factor out the y. If I factor out the y, I get y times x minus 1 is 2x minus 2. And then divide by x minus 1. If I divide by x minus 1, I get that right there. And remember, the y, when we're done, we're going to write it like that with function notation. 16, last one, there's absolutely 0 work on 16. You remember your shifts. We're going to shift 3 to the left. 1, 2, 3, 4 down. 1, 2, 3, 4. I'm starting, there's my vertex. Because there's a 1 in front of my absolute value, I'm going to go up 1 over 1, up 1 over 1. There's my 3 points. Draw your V. Absolute value equation is always a V shape. That's all you got to do for 16. All right, quite a bit of stuff on that one. Last one, hope it helps. I'll be here all day tomorrow if you need to come see me. Please come find me. Love to help you. Do great.